not discussed OOPS features in the beginning because my intention is to save a lot of time. That's why whenever time is coming, I'm discussing those topics. Even if I discuss in the earlier stages, you can't understand because right time should come for anything to happen, is it not? So now this is the time we can discuss about inheritance. In the beginning itself, if I talk about inheritance, you can't understand. That's why I have avoided those things. But whenever time is there, I'm introducing them just like keywords. So in the beginning, a couple of days before, in the beginning itself, I have introduced only one of the OOP feature, that is class and object. That is one OOPS feature. And then after that, yesterday, day before yesterday, we have completed polymorphism. That is also one of the OOPS features. Whether you take C++ or Java, same. And we studied that thoroughly. And now inheritance is also one of the OOPS features. And then data abstraction encapsulation will also come during packages. I will discuss about that. And then message passing, and then what is the other one? Data binding. Data binding means the kind of decisions you are going to take, like runtime polymorphism, compile time polymorphism, they are all part of that. So how the control gets transferred from call to different methods, that's all about that. So now we will discuss about inheritance. This is also one of the important OOPS features. A lot of advantages are there with this. Creating a new class, simple definition is creating a new class, existing class is inheritance. Creating a new class from an existing class. In this context, that new class can be called as class, can be also called as derived class. You can call it as derived class. You can also call it as subclass, or otherwise child class. You can also call it as class. And the old class, what about that old class? Because in the definition, you are getting two new things. Creating a new class from an existing class. Can I call existing class as old class? Yes. Old class. Old means existing. Yeah. Existing class. So this existing class can be called as, just give opposite words to derived. Derived. Opposite word for derived is base class. Base. You can call it as base class. Sub, superclass. Superclass. Child, opposite is parent class. Yes. So that is about that. Creating a new class from an existing class means some relation is there between both the classes. Parent and child relation is there. Otherwise, in books, majority cases they will write this definition: acquisition of base class features into derived class. Acquisition means acquiring, getting. Acquisition, acquisition of base class features into derived class. Derived class. That is also correct. Acquiring base class features into derived class means child is getting some features from parent, because the other name for derived class is, what is that? Child class. Yes. So child getting some features from base means parent. Got it? So be strong with terms, then you can easily define whatever way you want. Acquisition of base class. Acquisition means acquiring, getting base class features into derived class. Acquisition of base class features into derived class is known as inheritance. Right. What is the advantage of inheritance? Advantage. You can understand the advantage through program only. Now you can't understand. After get telling program again, I will come back and explaining this. Just 1 second, my charging is done. Let me- Right. So advantage is Code reusability is the advantage of inheritance. Code reusability. Lot of advantage. This is the biggest advantage. The biggest advantage in OOPS feature. Code reusability means what? You write code once, for example, declaration of variables or initialization of variables or some methods. You do once. In the next class, you need not do that. Automatically, they will pass to the next level. If you relate that new class with the old class, again, you need not do all that whole lot of code again and again. That is the advantage of inheritance. Okay, that is code reusability. You will see through program, you can understand. And then types of inheritance. Types of inheritance. There are only two types of inheritances in Java. Types of inheritance. Only two types. One, simple inheritance. Simple inheritance. As per Java documentation, only two types are there. But for commercial purposes, some people say three, four, five, they will say, but only two types are there. Simple can be also called as single level inheritance. That is, in C++, we call it as single level. Single level. That's right. The other one is multi-level inheritance. It's only two types. So what is single level? We will see first of all. What is simple inheritance? We will see. This one we will focus. Let us focus on this first. So there will be only one parent class and one child class as well. One parent, one child. One parent will be there and one child will be there as well. That is about simple inheritance. Let me put it in this way. I write class A. Class A will be having some features, as you know. Features means generally what does a class consist of? A class is binded with variables and methods, right? So those are the features. Let me call those variables as variables 1 and methods as 1. I closed the class over. Now see here. This one I am giving without inheritance. Let me give one example without inheritance first of all. Inheritance. This is an example without inheritance. No inheritance between them. Different, both. Class B. Class B will be also having some variables, its own nature. And it will be having its own methods as well. Methods too. So totally different. Nothing is shared, nothing is passed from one to another. Is it not? So in class A, these are the features. In class B, these are the features. No common features between them. Is it not? But let me go with inheritance this time. Let me go with inheritance this time. Copy. Let me go with inheritance this time. See the difference. Same thing. Here also, let me copy and paste this. Otherwise, I will make small adjustments here. So I copied and pasted same without inheritance, but see the changes which I am making. Here I am going to use a keyword called as extends A, right? So B is coming from A, means some relation is there. This phrase is missing in the previous example. Here class B is different, class A is different, no relation between them. Class A is having methods 1 and variables 1. Class B is having methods 2 and variables 2. But here, with inheritance, see the difference. Class A is having variables 1, methods 1, and class B is coming from where? Extents is a keyword. It is coming all the way from A. Means whatever features are there in class A, they will come to B also. Like this. Variables 1, they will come. You need not do. Automatically they will come. They are visible in this area also. Methods 1. That is the difference. Now compare. In the previous one, class A consists of methods 1, variables 1. Class 2 consists of, that is different story, variables 2, methods 2. But here, this time, with inheritance, I used a keyword extends and I related B with A in terms of parent and child relation. A is the parent, B is the child. Or you can call A is the base, B is the derived. Or A is super, B is subclass. Fine. But see, inside class A, whatever features are there, they are visible to class B also. They are visible. But previously, they are not visible because no relation. So that is one-to-one relation, simple relation, simple inheritance, or single level inheritance, one parent, one child. And B can be having its own features. These are B's own features, just like parent child. Child will be having some of his own features also, which our parent is not having, maybe. But other than that, parent is whatever whatever parent had, those genes will be transferred to child also, like this. Some at least. Here also same thing. You can sometimes some of the data you can restrict, even not going to child also, that is also possible. We'll see later on that. During access specifiers, we'll come across with that packages before. Right. So this is simple inheritance. We will work on a simple program on that. And before that, let me give the structure of the other one, that is multi-level inheritance. Multi-level inheritance. The next one. It is something like this. Class A will be there. It will be having variables 1, right? And some methods like this. Fine. Let me close it. And class B is having relation with class B extends A. Whatever is there in A, they are transferred to B. Means I can copy these two because relation is there. Pasted here. And B can be having its own features as well in the name of this 2 and it's 2. And again, let me go with yet another class C. Extends is coming from B. See, see the hierarchy. A is the grandfather, B is father, just like parent. This is grandparent. You can say father or mother, whatever it is. So it is grandparent. This is parent. This is child. Okay. So you can keep on moving like that. So class C extends B, and C will be having whatever is there carried from B, it will be having. Means I can copy this and paste this, right? Variables 1, methods 1, because variables 1, methods 1 are from grandparent. They are not coming directly, they are coming via B. Whatever features are there in A, they are passed to C via B. No direct transmission, only through B they can be transmitted, right? Now C can be having its own features as well, like variables 3 and methods 3, right? Closing this. And like that, you can keep on moving like this. You can keep on developing n number of classes. You can have class n also like this. Okay. level class n extends uh, any class before that, whatever it is, extends the previous class. Whatever you write, you can extend so that you know things will be like that. So I'm not writing, but things will be, you can understand D, E, F. You can keep on moving ahead like that. Like variables one will be there. Otherwise, I will do one thing. Copy all this stuff here. Additionally, it will be having variables n, sorry, as well as methods n, like that. Okay. Like that, you can keep on moving. So now let us write one application with simple inheritance, and there we can understand code reusability and all these things. Simple. Otherwise, I'll go with class base. I'm taking base as class, or otherwise, as you wish, any name you can take. What is there? Class A. Example I have given like that. So let me go with some data inside class A, like int x. You can initialize there also, unlike C++. In C++, you cannot initialize here, but in Java, you can initialize, but I don't like to initialize there. So let me go with a method, void, let us say assign or find. Okay, I will go with assign. Assign is a user defined method, some method I have given here, right? So in that I'm going to initialize only x value. I forgot one thing telling in constructors. I think I will just recollect, we will have to recollect that invisible constructor. I have to talk about that. I forgot discussing about that today. If possible, at the end of the class I will talk about that also, because we shifted to method overloading yesterday, day before yesterday. I forgot telling you that. Yes, nobody reminded me as well, of course. X is equal to, let me go 4, go with 4. So that is done. Now let me add one more method, find 1, or let me say add, or square, that is better, square. I want to find square of that. So very simple, system dot square is equal to x into, you need not put brackets, it will come. Only for plus and minus you need to put inner brackets. Right, that is done. Let me close this class. I closed this class. You can see class A started. This is the variable which I have declared, and these are the methods. First method is assign. I have assigned x value with 4, and in the very next method I found square of that. Square of x, otherwise square of x is equal to x into x. Fine, I closed the class. You can see here. Now after that I'm starting with at another class B, but I want to put some relation with A class. Extends A means parent child relation is there. B is a child class for A class. So whatever you have done here, it is all available here also. You need not write that code again and again. So I will go with a different set of data. I'm not writing, but it is there, is it not? You may ask me, sir, you have written here, why you are not writing? Because you may think in that way, right? But what I am saying is, see here, whatever is there, here there is no inheritance. Sorry, here it is. Here, whatever is there, it will be transferred to here. I need not write, even if I don't mention it. This will speak about that. Means it is there also in program. I need not write. For your readability, I have written there, but x is there in B class also. X is available, assign is available, square is available. So I don't want to write that code again and again. Means I can reuse this. I can reuse this part of the code. I can again reuse here. That is what is code reusability. These are after all a small program. In really big programs, in place of this much code, I may be having hundreds of lines of code, thousands of lines of code. The same code, if I use extends, it all comes, though all those variables, all those methods, you can reutilize here for some other purpose. Yes, here see how I'm using them. Void. Let me find, let me say some. First of all, I have to initialize that, right? I'll call this as assign one, first one, to avoid confusion. ASSIZN assign to. Inside that, let me put y value as 5. Right. Then let me go with yet another method. Void. Let me say sum. Inside sum, I want to add x and y. System dot change this. Sum of sum, simply to say sum. I want to find sum for what? Here x plus y. Correct. Y is available here itself inside a class B. No problem with y. But from where x is coming? I have not done x in this code. It is coming all the way from there because I mean B is a child class for A. So x is going to come all the way from here. Superclass. It is coming to subclass. This class also. I closed this class also. Or otherwise I can go with the main method and then close this. Otherwise, as per your wish, if you want to close, you can close and go with another different class where you can create object. But here I want to put main method as part of this class, this method. Public static void main. Yes. Now what to do? So whenever you do like this, always make a habit to create object for child class. Okay, why I will explain. Child class is B, is it not? B is a child class. A is a parent class. Is it not? Parent class. Now let us create object for child. Always make it a habit to create object for most recent class, most recently born class. That is B class, child class. So just create object for B class. B obj is equal to new B, like this. And then with the help of this object, what can I do? Obj dot assign one, I can invoke. Because assign one is available in both the classes, I can invoke obj dot, what is that first one? Square. SQUA square. Book. And then obj dot assign two. Assign two I can invoke. And then obj dot, what is the other one? Sum. Right. Save. So where is main method present? Because two classes are there. Two classes, class A, class B. But in which class main method is present? Please ensure that. So main method is present inside class B. So with the name of B, you have to save it. Let me save that. B dot Java. Right. I saved the program. Let's run the program here. Yes, you got square of x 16 and sum equals 9. We got. So now let us start reading this program. How to interpret with this program. So whatever code is written, forget about that. Execution, this is the entry gate, Program execution starts from the opening brace of main method, whether it may be C or C++ or Java, whatever it is, execution starts from here. So what is the first step done? JVM will look at this line. B, is there any B class? Yes, B class is there. An object is created for B class. It will put a tick mark. Fine, accepted. And then obj, object dot assign one. Is there any assign one? It will check here. It will check here. Any assign one? No. Assign two is there, but where is assign one? Immediately it will check the relation of B, just like police job. Police how catches a thief. So they go to their house. If he is not available there, is he having relation with anybody? He will check. Yes, B is having relation with A. So it goes to its parent class, A. Their assign one is available. Accepted. Fine. It will execute this portion of code. Okay, even assign one is not there. You cannot see here, but still it is part of this. How can you say it is part of this? Because it is having relation with A as parent child relation is there. So control transfers to A class, and it finds assign one and it executes that code. And what is executed? X is assigned with 4. Fine, done. Non-static variable x, non-static method assign one, no issue. X will be assigned with 4. That is done. Afterwards, what is happening? Obj dot square, it is also not there in this class. What to do? It will check whether B class is having relation with any other class. Yes, A class. It goes there. Object belongs to B class, but B is having relation with A class. That's why it goes there. With the help of the same object, you can invoke square also, because parent features will come to child. So system, what is that? Square of x equals 16. 16 is the output. Next statement. Obj dot assign to here itself it is present. This code will be executed fine without any problem. Y is initialized with 5. Fine. And then obj dot sum. What is that sum? Yeah, that is also there. No problem at all. Sum is equal to, but x is a problem. Where is x? No x here. So it checks the relation. Yes, again it goes to A and picks that A. What is that x? X is 4. You need not give again that x equals 4 here. It will pick from its parent class. That is code reusability. You need not unnecessarily write code every time. You can get it from super class. So x plus that x 4 plus 5, that is 9. Done. Is it not? Any doubts in this program? Please ask me. But always
సార్
make a, yeah, yes.
సార్ ఇప్పుడు
Yes.
అసైన్మెంట్ లో స్క్వేర్ అట్లా రెండు రాశారు కదా సార్, రెండు ఫంక్షన్స్. అదే దాని బదులు కన్స్ట్రక్టర్ యూస్ చేసి
చేయొచ్చు.
పారామీటర్స్ పాస్ చేయొచ్చు కదా సార్.
కన్స్ట్రక్టర్ తీసుకుని చెయ్యొచ్చు. బట్ కన్స్ట్రక్టర్ అంటే ఏకి కన్స్ట్రక్టర్ కదా, అప్పుడు ఆబ్జెక్ట్ క్రియేట్ చేయాల్సి వస్తుంది కదా దానికి. చేయొచ్చు, చేద్దాం అది కూడా చేద్దాము. ఐ విల్ డూ దట్ ఆల్సో. జస్ట్ ఎ మినిట్. రైట్. ఎనీ అదర్ డౌట్స్? ఐ విల్ డూ దట్. వెయిట్. ఎనీ అదర్ డౌట్స్ అదర్ దాన్ దట్ in this particular
నో
program?
డౌట్స్ సార్.
Right.
నో
Let
డౌట్స్.
me do that way also. Copy. Let us go with that. So you are saying constructor. For that I had to go with this A. Okay, done. After that that is okay. Any other changes you want? Only one constructor is enough for you?
లోపల పారామీటర్ పాస్ చేయొచ్చు కదా సార్.
చేయొచ్చు. If you want you can do that. What is that? Yeah. And here you first I will try with this, then I will do that also, because if any complication is there we have to check now. And moreover, I have to change the names. Let me change A1, and let me change here also A1. What else I need to change? B1, because this is another program, right? We're adding another program. Fine, fine. So here also B1, B1. What else? Enough? Right. Any other mistakes? Let us check. B1.java. Let me run this. If any mistake is there, we'll modify. Don't worry. What is that? obj.assign1. obj.assign1. Variable obj of type b1. Obj of type, what is that? Already saying method assign one. Variable obj of type b1 cannot, that is the problem with. Oh, assign1 is no more available, right? Yeah, yeah. We changed code, is it not? Okay. Only assign 2 is there, otherwise I'll make this as assign simply. Only one assign is there, is it not? Yes, right, true. Because we changed code, we have taken a constructor in place of that. Yes, I'll explain, don't worry, I will explain. No problem. See, this is a very good one. So you can place a constructor also. The thing is that what is happening here? Let us examine the code. Whenever you create an object, uh, so in the beginning, in the middle of the class, I told you one thing I am missing. I missed telling you. What is that? Constructor. Hmm? So I need not tell that program again. In this program itself, that is self-explanatory. So a default constructor is in. Of course, I have written orally. Literally, I have given that anyways. So default constructor is invoked here. So an object is created for B1 class, but still that A1 constructor is invoked or not. See the output. A1 constructor is invoked or not. You got output 16 and sum is 9. Yeah, both square and sum worked fine. So whenever you created object for child class, first thing is it will look for constructors. So an object is created for child, and child means it is having relation with parent. So parent class constructor will be invoked. Automatically it will be invoked. This is invoked. You need not separately say A1, what is that? A1 obj is equal to new A1. That is not required. So this will be invoked. This is done. This code is done. So x is assigned with 4. Parameterized, I will show you. First, let us see this. I will go with that variation as well. So whenever you create an object, default constructor is invoked. So how to invoke a constructor? I told a couple of classes before. Just create an object. But in this case, I'm not creating object for parent class. I am creating object for child class. That is pretty enough to invoke, because it is related with parent, and any parent constructor is there, it will look at that, it will invoke that. And then comes the next step, that is obj dot square. Yeah, square is not present here. Same story, I need not repeat. Square is present in its parent. Yeah, it will go for its parent class. In parent class, square is there, it will run this. Relation is there now. B1 is related with A1. It goes for that and it runs that. Fine. And then assign, here itself it is available, it will do that. Sum, yeah, here itself it is available. And x you got from constructor, right? Any doubts in this program? Any of you? Just little change I made. Constructor. How to invoke a constructor? An object should be created. For what? For either this class or this class. I have gone object for this class. If I create object for this class, square can work, but what about assign? That is the problem. Even square I have to invoke with the help of this object. That's why I always make it a habit to create object for child class, because child is rich enough when compared with parent, just like in practicality. Is it not? Because child will be having his own earnings, as well as his parents' earnings. That's why child is always rich enough, always create object for child class. In some exceptional cases, sometimes may be required to create object for parent also, but most of the cases it will be easier for you, because you can, because inheritance, that is the flavor of inheritance. Everything will come down, top down approach will be there, transfer of features will be there. That's why you can create object to child class and invoke all parent features and child features itself as well. So I think this is enough, and now I will go with parameterizer as you asked. Let me change as per your interest. I go with a parameterizer constructor this time. Int x, time is ticking again, you get back 1 minute. It is int x. Here it is not required. It is required. It is not required. Right, right. And this is also not required. Of course, it is coming from there now. So what can I do? I do one thing. Even I don't want to go with square also. This is better. This is better, right? That x will come from somewhere. Don't worry. Don't worry about that x. Yes. From where? Here. But here you need to invoke that parameter